last example, example 9 for this review. Here's a problem that I created just for the review. And what I want to do is find I naught through this 2 ohm resistor. And the way to do that is to first find I here, all right, the current through there, and then use current division. All right, so how do I find I here? Well, I notice that I have 4 in parallel with 2, which gives me 1.33 ohms. All right, and then I can take 2.67 plus 1.33 because they're in series, and I get a total of 4 ohms. All right, so now my circuit is going to look as follows: 1 amp with a 2 ohm resistor here, and then 4 ohms in parallel with 4 ohms. All right, so it turns out that this 1 amp is still 1 amp here, so I can use current division. Because what I would really like is to find still I here, which is the current through the 4 ohm resistance. It's the combination of the 3 resistors over here. Okay, so use current division. All right, and so I would see that I have I here equal to the resistor I don't want, in this case 4, over the sum of the resistances multiplied by the input current, which is 1 amp. This is going to be equal to 1/2 amp. All right, so now we come back to our original circuit, and we know what the input current I here is. All right, so I know that this is going to be 1/2 of an amp. And here we have 4 ohms, and here we have 2 ohms. So again, we're going to use current division. All right, so I naught, which is what we're looking for, is equal to the resistor we don't want divided by the sum of the resistors, and then multiplied by the input current, which in this case is 1/2. All right, so we're going to get 2/3 of 1/2, which is just equal to 1/3 of an amp, or 0.33 amps. And if we think about this, this makes sense. In order to get up to 1/2, we would take 1/3 and we would add to it like 1/6, right? Because that's 2/6 plus 1/6 equals to 1/2. And so this makes sense that more current is going through the smaller resistor. All right, so this is just logical. A few easy steps to solve what could be a complicated problem.